Hi guys, I hope you're having a good weekend. So we're starting a new unit on polynomials. A polynomial is a function with more than one term. Like a quadratic is a type of polynomial with a degree of 2. A cubic is a type of polynomial with a degree 3. So it has multiple terms, like for example, x cubed plus 2x squared plus x minus 4 equals 0. That's a type of polynomial. So we're going to go ahead and look at some more polynomials, starting off with some applications of polynomials. So first of all, we have the open box problem. An open box can be made by cutting out squares from the corners of a 9-inch by 12-inch rectangular sheet of cardboard and folding up the sides. Find the dimensions of the box that maximizes this volume. And then here's your volume formula. So the first thing we want to do here is we want to draw a 9 by 12-inch rectangular sheet. So I'm going to make my 9 inches my width and 12 my length. So this side over here, this whole side is going to be 9. And we have 12 inches for my length. 9 by 12, rectangular sheet. Now it says that we're cutting out squares from the corners. So since we're cutting, okay, we're going to use a dotted line or a dashed line to represent the cut. And since they are squares, I'm going to cut, a square off each corner. So there's one square. I'm trying to make all these squares the same size. But remember, this is just a sketch. Okay, and there's something that we do know about squares. We do know that squares have equal side lengths. So what we would want to do next is we would want to give a side length a variable, because we don't know how big these squares are. So I'm going to make the side length of the square x. So it'd be x by x. So each side length will be x by x on each square. Okay? So the next thing we're going to do here is we're going to write the function. So we have volume equals length times width times height. And we want to find the dimensions of this box that will maximize the volume. And that's going to depend on how big we make these corners. Okay? So first thing we're going to do is we're going to write the function. So volume is going to be equal to the length. Okay, so I need a quantity to represent the length of my box. Well, we know it's 12, but we're cutting out 2 squares. So our actual length is actually, of our box, is actually going to be from here to here. Because these are going to be folded up. Okay? And so the length of my box is going to be the total minus the 2 x's, because I'm cutting those out. So that's going to represent the length. Multiplied times the width. So the width, okay, it's going to be 9 minus the 2 x's. So that's going to be our width. And then multiplied times our height. Well, our height is going to be, so if I'm going to fold this up, that's going to be the height of my box. So we know that this height is going to be x. Right here. Because when we fold it up, this portion right here will be going straight up in the air, and that will be our height. Okay. next thing we want to do here is we want to make a sketch of this. So we're going to graph this over here. So first of all, x, since all of these are in terms of x, I could write this as volume in terms of x, a v of x, because the variable is x. The volume of the box is going to depend on whatever value x is. So let's go ahead and go to our calculator. Hopefully we get a good screen here. Click OK, go to New Doc, click No, Add Graphs. Okay, so I'm going to go ahead and plug in my function. So we have 12 minus 2x times 9 minus 2x times x. So there's my volume based on, here's my length, width, and height, all in terms of x. So remember, the height is x. Okay, so let's graph it. Okay, so we got this funky looking graph here. So what is going to be, first of all, what is going to be our minimum height? Okay, so 0 would mean that we would have no height on our box. Okay, so for our domain, we're going to start it at 0. Okay, but we don't want a height of 0. So our domain is going to be greater than, so the x, the height is going to be greater than 0. But it's going to be less than a maximum height, which we're going to find out what that is in just a minute. So what we want to do next is we want to zoom out, and I'm trying to remember how to do this. So let's try to go to Menu, Window, and I want to zoom out. Let's see, center, I guess. I want to center it right in here because that's where I'm looking. Okay, so notice it's going up and it's coming down. Looks like we're going to need to zoom out some more. Wow. I think we're going to go ahead and mess with the table here because I don't like the way this zoom is looking. So let's get to the table. So let's go to Menu, Table. That's not the table. That's not what I need. Let's try going to the window. Remember, I'm still learning this as well. So window settings, the top one. So my x-min, that's going to be our minimum height. We're just going to go with 0, even though we know we're going to be much larger than that. X-maximum, well, let's just go with a maximum. We know that the maximum length is 12. Okay, so we know it's going to be smaller than that because we can't make two cuts that are bigger than 12. That we have 12 total. So let's just go, say, to 10. And we'll go ahead and go by ones. Okay, so our Y minimum, so our minimum volume, because remember, V is the volume, and that's our Y. So let's go 0. Now, remember we were trying to, back on the graph, it was going up so high. So it's going to be up there a ways. So I'm just going to guess here. Let's go with 500. And we'll go by 50s. And let's see what we got. We might have to change it. Okay. That might work. The one thing I don't like about it is I can't see my x-axis. So let's go back in the menu. And let's just drop it. Remember, this is just so that we can see the graph. So let's drop our y minimum down a little bit. Let's go down to -50 so we can see it. Okay, so we can see the x-axis a little bit. All right, so we're only looking at this portion here. Height is 0, okay, and as height goes up, the volume, remember volume is y, and remember, we're looking for the maximum volume. So what we're really looking for here is our maximum height. So this portion over here, we don't even look at because it's going up infinitely, and that's impossible. This is an unreasonable part of the graph. We always have to think about our dimensions and our maximum height. Our maximum height couldn't be over 12, and actually it couldn't even be over 9 because here 9 is the largest width we could have. So we couldn't even go over 9. So we could actually go a little bit smaller than that. But so what we're looking for is our maximum height right here. So let's go ahead and maximize this menu. And we'll analyze the graph. We're looking for maximum. And we'll go to the left of the maximum. And then to the right. This thing goes so slow. Okay, so it looks like our maximum is, the height is going to be 1.7. Remember, that's x. Don't forget, back on our formula, that x represents the height. So our maximum height is 1.7. And so 81.9 is our y. Don't forget, y is your volume. So it looks like our maximum volume for this problem is going to be 81.9. Okay, so how do we sketch this graph? Well, so we know we want to go up to 81.9 over here. So I'm going to go ahead and go by 20s. So 20, 40, 60, 80, 100. I want to at least go above the maximum height. Okay? And then on the x-axis, it looks like it's going to go from 0, 1, 2, 3, 4, 5. So we could go to 5. So 1, 2, 3, 4, 5. And remember, we're on the x-axis here, so this here is going to represent our height, and it's in terms of inches. And this is going to represent our volume over here. So 1.7, 81. So about right here is going to be our maximum height. So we're going to draw a curve up, and it's going to curve down. It looks like it's going to go down somewhere in here. So our domain is going to go, and I'm just kind of eyeballing it on my graph, about less than 4.5, just eyeballing it. And then my range, 0 is my lowest, 81.9 is my highest, my maximum. Okay? And yeah, I'm running out of time here, but let's just fill in the information. Maximum volume, 81.9 cubic inches. We got that. What are the dimensions? So we know that our maximum height is 1.7. So that's going to be our height. All right, we'll finish